Hello students, in today's lecture we will be introducing you to all the basic terms that will come in electromagnetic wave in conducting media, all the basic formulas that will be used and we will be deriving in the next lecture. So what was the status of electromagnetic wave when it moved in a conducting media is that the electromagnetic wave when it moves in a conducting media, the E and H vectors are, that is, the E is electric field intensity, H magnetic field intensity. They both are traveling perpendicular to each other and are traveling in the direction of propagation of wave. EMT waves are transverse in nature. E and H fields are damped exponentially as the wave keeps penetrating in the conducting media. The field vectors E and H are not in phase with each other when it comes to EMT wave in conducting media. But what happens is that magnetic field vector H lags behind electric field vector E by an angle phi, where phi is equal to half tan inverse conductivity sigma upon epsilon omega, where epsilon is permittivity and omega is angular frequency. We will derive all this right now. Just remember one thing, that the magnetic energy density in much greater than electric energy density, and they both, electric and magnetic field in conducting media, are damped off exponentially and they are not in phase with each other, right? That means, once again I repeat, the electric field vector and the magnetic field vector, when an EMT wave travels in a conducting media, are not in phase with each other and they are damped off exponentially when they penetrate in the conducting media. Now let us look at all the basic formulas which we are going to derive in this lecture. The first, let us understand the symbols. Sigma means conductivity of that specific media. Omega is angular frequency, which is equal to 2 pi into linear frequency. Mu is permeability of the medium. Epsilon is permittivity of the medium. This we are talking is about the conducting media. What is the wave equation for an electromagnetic wave in conducting media? Del 2Ex upon del Z2 minus gamma square Ex is equal to 0. That means EMT wave propagates in a sinusoidal manner. That is, like a sine wave is how an EMT wave propagates in the media. Second word, propagation constant. That means, what is propagation constant? You represent it by gamma. We have derived in the previous lecture this expression, which is equal to, either you can write it, gamma is equal to under root J omega angular frequency, mu permeability, sigma conductivity, minus omega square mu epsilon. So what is propagation constant? It is a measure of change in amplitude and phase per unit distance. How much amplitude change has taken place and how much phase change has taken place when an EMT wave is traveling in a conducting media. Next, attenuation constant. Basically, attenuation in a broad manner means that how much the signal has decayed when it has entered the conducting media. So attenuation constant constant alpha is equal to, if you remember, propagation constant gamma was equal to alpha plus I beta, where alpha is attenuation constant and beta was phase constant. So for a conducting media, the attenuation constant alpha is equal to omega, angular frequency, under root mu permeability, epsilon permittivity divided by 2 under root 1 plus sigma conductivity omega epsilon square minus 1. That is attenuation constant, which is a measure of signal's rate of decay of EMT wave in the medium. Skin depth. Skin depth means the depth at which the EMT signal is going to attenuate. Basically, it is 1 upon E times, that is the exponential decay of its initial value. You can see exponentially the wave has decayed when it enters a media. So this is known as skin depth. It is equal to 1 upon attenuation constant, or it is inverse of attenuation constant. Next comes phase constant. See, phase constant is telling us what proportion a sign has shifted along the x-axis. So phase constant beta will be equal to omega under root mu epsilon by 2 into under root 1 plus sigma omega epsilon square plus 1. Here it was minus 1. Here it is plus 1. This is phase constant. Next comes phase velocity and wavelength. Phase velocity is the speed at which a wave's phase propagates in the media, and obviously wavelength is the EMT wave, how much wavelength it is going to carry in a conducting media. So it is phase velocity is given by 1 upon under root mu epsilon divided by 2 into under root 1 plus sigma upon omega epsilon square plus 1, and lambda is 2 pi of this. Intrinsic impedance. The impedance word means what a wave is, impedance and wave is facing when it is traveling through a media. So intrinsic impedance is given by neta is equal to under root j omega mu upon sigma plus j omega epsilon, and if you talk about it in vacuum or air, neta is equal to under root mu naught upon epsilon naught. Mathematically, the value comes out as 377 or 376.66. Now, let us begin to derive all these expressions.